Alright, here we're going to be analyzing a simple series circuit. You have a 6-volt battery in series with 5 ohms and 7 ohm resistor. Okay, simplify the circuit to find the equivalent resistance. The first step in analyzing any circuit is to look at it and simplify it to one equivalent resistor. So if we look at this, we see that 5 and 7, alright, are in series, and there's one current passing through each. So the equivalent resistance for series is 5 ohms plus 7 ohms will equal 12 ohms. So I can redraw this to be a 6-volt battery in series with a 12 ohm resistor. Alright, that would be A. B, we would then find the current for the circuit. We would have I is equal to delta V over R, where you'd have 6 volts divided by 12 ohms, and this would equal 0.5 amps. Alright, now, there's your answer to B. So if we look at this, we know that 0.5 amps goes through the 12 ohm resistor. Well, if we work backwards now and start looking at this 0.5 amps going through 5 ohms, 7 ohms, we can then find the voltage across each resistor. So since we know this 0.5 amps goes through 5 ohms and 7 ohms, we can state the following. For the voltage across the 5 ohm resistor, we know the current will be 0.5 amps. We know the resistance will be 5 ohms. So all I did here was take Ohm's law and rewrite this as I times R is equal to delta V. And this would then be 2.5 volts across the 5 ohm resistor. Then across the 7 ohm resistor, this would be 0.5 amps times 7 ohms is equal to 3.5 volts. Alright, so to double check our work, we know that the loop rule says that all the voltages in a series loop will add up to equal 0. So if we have 6 volts given to the circuit by the battery, we have 2.5 lost and 3.5 lost to the 5 ohm and 7 ohm resistor. We know that they add up to be 6 total. So the whole loop, the voltage will equal 0. Alright, now for the graph here. So if we look at this, if we start in the left hand corner here, and we say that at this point delta V, or not delta V, but just V is equal to 0 volts. Okay, as we go from the negative side of the battery to the positive side of the battery, our graph's going to spike up across here to be 6 volts. Alright, the voltage is not going to change until it hits the 5 ohm resistor. It will change by 2.5 volts. So this will then come down to right above 3 at 3.5 volts. Alright, it travels in the wire next to the 7 volt, or to the 7 ohm resistor. Well, we'll drop 3.5 volts all the way down to 0 till it hits the battery again. Then it will spike back up to 6 and drop. So this is what a voltage as a function of position of the circuit graph will look like. It just accounts for each voltage drop across the circuit element. So this drop here represents 2.5 volts across the 5 ohm resistor, and this here represents 7 across, or 3.5 volts across the 7 ohm resistor.